So my name is Peter Griffith with an ITH. I am a family guy, but I am not closely related at all to Peter Griffin. I share neither his intellect nor his physique. Um, and I am a carbon cycle scientist at NASA Goddard Space Flight Center.
Based in New York, is that right?
I'm actually based
Oh, Maryland.
in Greenbelt, Maryland. There is
Yeah,
a Goddard Institute of Space Studies, which is
right.
where really fabulous people like Gavin Schmidt and Kate Marvel um, are. And if you're not following them on Twitter or something, you should, because they're both pretty awesome.
I'm
But
following
I'm
them.
Yeah, but I'm at Goddard Space Flight Center, which is like the parent institution for Goddard Institute of Space Studies.
Oh, okay.
And we are actually NASA's oldest campus that was created by once the agency existed. So NASA is about to celebrate its 60th anniversary, and Goddard is, I think, in year 58 or something like that of
Oh,
NASA's.
wow.
Yeah.
So even older than the Jet Propulsion Laboratory?
So so Jet Propulsion Lab was created before NASA existed.
Oh, I see. Okay.
Yeah. So and JPL has sort of a complex relationship to NASA because it's actually uh, a contract with Caltech that
All right.
operates JPL. So it is deeply connected to NASA, but it is not a NASA center like Johnson or Kennedy Space Center or Goddard.
Okay.
I don't have that link to the.
Oh, I sent it to you in Skype, I think. Did I not?
I don't see
In the
it.
chat in Skype? Do you see? It should have just popped up as like a Twitch.
Yeah, you would think so. Let's
Oh,
see.
here, I'll send it to an email or something. Um, let's see.
And my apologies to the multitudes that are following on Twitch that it's taken that so long to get going.
It's quite all right. It's always the first time uh, I did this, it was a complete mess, and I think here we'll at least get a good 30 minutes of solid
Okay.
content. So,
So I'm working with a couple of projects that are um, really closely connected with the changes that are happening with the carbon cycle on Earth, um, as and then linked into climate change. So one of them is something called the Arctic Boreal Vulnerability Experiment, which is a real mouthful, uh,
okay,
but
I
it
sent
has
you the Twitch link in email in that thread we were talking before.
still waiting for that to show up, and that is so that project. The short name for it is Above.
Okay.
Uh, so you can find people interested in it can find more on above.nasa.gov. Oh, now it's asking me to log into to Twitch. So everything.
Yeah, Partis Prime, you can ask us questions in climate chat here. So we have another viewer just joined us in Twitch chat. Um, so you could probably read the chat without logging in, but if you want to participate in the text chat, you'll have to log in, Peter.
Okay, I'm working on that.
Okay. Yeah, so I don't know. So is the boreal carbon cycle, is that thinking about things like permafrost and
Exactly. So
what?
permafrost is one of the biggest um, topics with that. Oh my goodness, somebody already has CO2. That's rude. So why is it not? So whatever that, here, let me try connecting with Facebook. Let's see if that'll,
Okay.
maybe that'll be faster. Okay, and now I've got a big screen of stuff that. So anyway, I should probably try to address the question, which is the Arctic is warming fast and first on the planet, which is something that we expect to happen from climate models.
Right.
This is something that 25, 30 years ago, people who were doing modeling were predicting that there would be warming sooner in the Arctic than anywhere else. And unfortunately, that's what we're seeing in the observations that are playing out.
Yeah, so this is, people refer to this as Arctic amplification.
Exactly. Now I've got a little bit of echo in mine for some reason, even though I've got the headphones on.
We have the Twitch. You're probably also listening to the Twitch voice now.
Oh,
So you just want to mute that probably.
okay, let's see. Actually, it's a little bit better right now. I'm not getting it. So because of that, NASA, several years ago, we started working on an experiment plan to look at the ecosystem and societal impacts of environmental change in the high northern latitudes of North America. So basically, we're working across Alaska, the Yukon Territory in Canada, and Northwest Territories in Canada, which are like off of everybody's mental map. It's not a place that you even sort of think about when you think about Canada. It's way up there.
Right.
And the permafrost is thawing, and the old organic carbon, this is, like mastodons and forests from 40,000 years ago that are buried and frozen in this ice-rich soil, is starting to thaw, and this organic carbon is being chewed up by bacteria and is being released into the atmosphere either as carbon dioxide and methane, which of course are greenhouse gases. And so the concern is that that's going to even amplify the already, ramped up greenhouse effect in that part of the planet.
Right, and those emissions would also amplify the warming everywhere else, not just there, right?
Absolutely, because carbon dioxide and methane are well mixed greenhouse gases, meaning that they that emissions that maybe people cause by burning the Amazon don't just stay in the Amazon, or burning coal don't just stay in Ohio. Thawing permafrost CO2 emissions don't just stay in the Arctic.
Right. So what kind of programs do you guys have to try and understand things about, like how do you guys actually learn things about these systems at NASA?
So the big thing with NASA is that we try to do things that that intrinsically involve airborne and satellite remote sensing. So there are lots and lots of ground sites around this part of North America. A few dozen in Alaska, another few dozen across an area several times bigger than Alaska in Canada, and they give us a lot of information about what's happening in one particular part of the forest or one particular part of the tundra, But what NASA brings in is aircraft where we can fly across those sites to get these sites where there's really good ground validation, but then scale that information across large geographic areas. I think last year we flew an area of almost 4 million square kilometers. And then we can use the aircraft information to better understand what it is that we see from space with satellites.
Okay. So if you see, I guess the way that you get the methane emissions, for example, would be by seeing higher methane concentrations over a particular area or something. So how would you separate, for example, permafrost methane versus, human emissions of methane or even something else that's emitting methane?
Hey, that's a deep question. Maybe I can back up a little bit just to say something about how it is that we know that the increase in carbon dioxide concentration that has been observed over my lifetime, because I'm as old as the Keeling curve, which was started by Charles Keeling in the late 50s, when he started doing really precise measurements of carbon dioxide. At first at Scripps Pier in La Jolla, California, and then he said, you know what, there's too much influence here in California from cars and trucks and power plants and stuff like that. So he went to the top of a volcano in Hawaii to start extending those measurements, because, spoiler alert, volcanoes are not the source of the increasing carbon dioxide that we see in the atmosphere, and started this long time series of precise carbon dioxide measurements. And we know that the increase in carbon dioxide is from human emissions, because that are a combination of burning fossil fuels and also of tropical deforestation. One of the ways that we can look at that and know that it's because of fossil fuel combustion is because the composition of the different types of carbon that one measures in the atmosphere is distinctly different from what comes off of burning fossil fuels versus what is just the natural exchange of carbon dioxide with the biosphere. This is done by looking at, and I don't know what I don't know what our audience is right now, so I don't know, where to go in this. But basically, there's different types of carbon on the planet. Some of the carbon on the planet weighs, you can think of, if you had a bucket of carbon-12, that it weighs 12 pounds a bucket. If you have a bucket of carbon-13, it weighs 13 pounds. A bucket of carbon-14, it weighs 14 pounds a bucket. And those different weights of carbon are called isotopes. And we can look at the different isotopes of carbon in the atmosphere and understand what the sources of the carbon are. And by looking at fossil fuel emissions, there's absolutely no carbon-14 in the fossil fuel emissions, because it's very, very old, and carbon-14 is radioactive. And so when you burn fossil fuels, whether it's oil or gas or coal, there's no carbon-14 left in that.
Right.
Uh,
So
so
if I'm not mistaken, the same, I think also one of the Keelings, either Charles or Ralph Keeling, they've also looked at the concentrations of oxygen in the atmosphere, and because that also gets taken up when you burn fossil fuels, and so you can actually measure the decrease in oxygen in the atmosphere. Is that right?
yes, that's correct, and that's Charles Keeling's son, Ralph,
Okay.
has really been the one who's continued that work, and a lot of his work is involved in looking um, at the decrease in the amount of oxygen in the atmosphere. Now, don't worry, we're not going to run out of oxygen anytime soon, because the atmosphere is mostly nitrogen and 20 something percent oxygen, and the amount of carbon dioxide is much lower than that. So it's not like we're about to use up all of the oxygen, uh, but we can look um, at these very small decreases in the amount of oxygen in the atmosphere that mirror the increase in carbon dioxide.
Um, so I think we had gotten on sort of a tangent where we were thinking about measuring the greenhouse gas emissions from planes in the Arctic.
Right. So we have a combination of ground sites that where we have these things called flux towers um, that are instruments that measure the movement of air, of water vapor, of carbon dioxide, and of methane between the land, water, surface, and the atmosphere. And these sort of have we call it a footprint of CO2 and methane exchange that let us see the plants taking up carbon dioxide and the respiration of all the plants and animals and microbes of the environment releasing carbon dioxide and methane into the atmosphere. Um, so that's sort of like the the base level for the ground observation of how much CO2 and methane is going up into the atmosphere. Um, then, but those are only, those only tell you what's happening within a few hundred meters of the flux tower. So then to that we add aircraft that are flying around um, with air sampling equipment that fly all the way around Alaska and northern Canada over the course of several days. One of these aircraft can make the circuit and measure the CO2 and the methane um, across the whole region. And those observations are put into weather models. Essentially, you can think um, of a weather model that adds carbon dioxide and methane to it, so that you can estimate the changes of CO2 and methane that occur across a landscape.
Right.